Tomorrow's Secrets, Discoveries We Haven't Made Yet. Chapter 1. New Elementary Particles Overview. In the 20th century, physicists revolutionized our understanding of matter with the discovery of the Standard Model, a complex, intricate tapestry describing the fundamental particles governing the universe. This model provided a solid foundation to describe almost all physical phenomena observed so far, from the behavior of electrons and atoms to the interactions of protons in a particle accelerator. And yet, like all monumental achievements, the Standard Model left questions unanswered, gaps that even the Higgs boson couldn't quite fill. Today, scientists, assisted by sophisticated AI algorithms, are peering beyond this paradigm, searching for hidden particles that could redefine the very fabric of reality. AI's speculative contribution. Imagine an AI-powered particle collider, an unfathomably intricate machine designed not only to replicate conditions of the early universe, but to go beyond what human intuition could grasp. AI-driven algorithms tirelessly simulate and recalibrate every particle interaction at scales and speeds impossible for any human mind to process. These systems hunt for anomalies, subtle blips that could signify new particles. What might they discover? Particles smaller than quarks, perhaps, or entities that warp dimensions we haven't yet imagined. Scientists postulate the existence of dark matter particles, unknown particles that exert gravitational forces yet remain undetectable by conventional methods. AI steps in as a relentless detective, building predictive models and running virtual experiments with billions of theoretical particles. Within months of initiating its search, this AI system might detect a pattern. Not one particle, but a family of particles exhibiting unique, subtle gravitational effects. These particles could be part of the elusive dark sector, a parallel framework that exists alongside our own, but interacts only faintly with what we know as matter. The discovery unfolds. Picture a scene in a cavernous underground lab, scientists and engineers watching a live feed from the AI collider as numbers flicker across the screen in rapid succession. An unusual signal appears, short, elusive, and unmistakably unique. It's a moment charged with anticipation. AI assistants analyze the data instantaneously, highlighting anomalies in particle trajectories and energy signatures. The scientists see it, a subtle deviation from the expected, one that repeats every 100 trillion collisions. In the coming months, AI models refine and replicate this phenomenon. The discovery points to particles of quintessential energy, existing in a state that transcends familiar forces like electromagnetism and gravity. These particles, aptly named quintessons, could provide a direct pathway to understanding dark energy, the mysterious force accelerating the expansion of the universe. Their behavior hints at properties alien to human understanding, particles that phase in and out of our observable reality, interacting only briefly before disappearing beyond our reach. Implications of the discovery. The implications of quintessential particles are profound. For the first time, scientists glimpse a force beyond the four known interactions: electromagnetism, gravity, strong and weak nuclear forces. Quintessons might explain why galaxies are not tearing apart, holding clues to the architecture of the cosmos that we never imagined. The ability to harness this energy, even theoretically, could usher in a new era of cosmological exploration, allowing humanity to interact with the fabric of space itself. Furthermore, quintessons challenge our understanding of mass, time, and causality. The discovery suggests that mass is not simply an inherent property, but an emergent phenomenon, generated through complex interactions with these fundamental particles. AI simulations theorize how altering quintessential fields could result in dramatic shifts in gravity, perhaps even allowing for localized gravity wells or manipulating space-time itself. Such a discovery would inevitably lead to ethical discussions. Do we have the right to tamper with such forces? The power to create mini black holes or warp space for interstellar travel could come with consequences as unpredictable as they are monumental. What it means for humanity. With the discovery of quintessons, the nature of existence feels both enriched and vulnerable. As we begin to grasp the structure of reality, the need for responsibility becomes glaringly apparent. Could such a discovery invite humanity to harness powers akin to those that form stars and galaxies? Or might it lead to existential risk, should this power be misused or misinterpreted? One might imagine a future where quintesson technology enables leaps in energy production, transportation, and computing power. but with great potential comes even greater moral responsibility. As Quintesson research advances, leaders in science and ethics will need to craft guidelines, ensuring that humanity respects the forces of the cosmos rather than dominating them recklessly. AI, our partner in discovery, will not only push the boundaries of our knowledge, but also help to remind us of the fragility of our place in the universe. Closing reflection. This first discovery sets a precedent for our journey through tomorrow's secrets. As we continue, we'll confront ideas that may seem equally far-fetched today, but will one day feel as real as electricity or the internet. With AI as both our guide and co-discoverer, we're only beginning to understand the potential hidden within the building blocks of reality. What might Quintesson particles teach us about our universe? And, if we were to unlock the power of the cosmos itself, would we wield it with the wisdom it demands? Chapter 2. Theory of Everything Overview. For over a century, physicists have pursued a unified theory that would seamlessly connect the realms of the very small, quantum mechanics, and the vast gravitational reaches of general relativity. Known as the theory of everything, TOE. This quest seeks an elegant framework to describe all fundamental forces and particles in a single, cohesive system. In many ways, it is the scientific holy grail, promising a deeper understanding of reality itself. Yet, even with advancements in both fields, TOE has remained elusive. Today, with AI's unparalleled computational ability and pattern recognition, scientists are closer than ever to cracking this grand enigma. AI's speculative contribution. Imagine an AI so advanced it can model the behavior of particles in space-time down to the smallest fluctuations and across unimaginable scales. This AI, trained on data from every physics experiment conducted to date, simulates trillions of possible interactions in real time, probing regions where quantum and gravitational effects collide. The result? AI identifies a recurring, subtle symmetry, a mathematical pattern that eludes human intuition but could be the missing link. This pattern holds steady across vast scales, hinting at a hidden structure within space-time itself. Here, AI plays the role of both creator and interpreter, guiding scientists toward a theory that spans everything from particle physics to cosmology. The discovery unfolds. In a futuristic research center, physicists and mathematicians gather around AI-generated models, each depicting a unique fusion of quantum and gravitational fields. A breakthrough comes when AI models a hypothetical particle, dubbed the gravitino, that bridges the gap between quantum mechanics and general relativity. The gravitino exhibits properties of both realms, existing in a quantum superposition, yet interacting with the fabric of space-time itself. For the first time, scientists observe a force that seamlessly operates across scales, unifying the micro and macro, the particle and the wave. The discovery of the gravitino leads to a cascade of insights. Researchers now see the possibility of new dimensions, curled within our observable universe, but inaccessible to traditional methods. AI simulations reveal these dimensions as energetic fields, each influencing particles subtly, yet profoundly. The theory begins to take shape, each layer built upon patterns and principles uncovered by AI, each revealing an intricate, space-time web that binds the universe together. Exploring the theory's depths, the discovery of the theory of everything goes beyond simply uniting quantum mechanics and relativity. It introduces an entirely new perspective, a dynamic space-time, where fields and particles influence one another in real time, generating ripples that echo across the cosmos. This dynamic model predicts behaviors never before imagined, such as particles that resonate with frequencies across galaxies or waves that create instantaneous connections between distant points. To visualize this, imagine two particles at opposite ends of the universe. According to the TOE, these particles share an invisible space-time resonance. A change in one instantaneously impacts the other, as if they are linked through the very fabric of reality. In our everyday lives, this phenomenon might resemble quantum entanglement, but at a cosmic scale, this interconnectedness hints at an even grander design. AI pushes deeper, applying complex algorithms that continuously refine the theory. Each simulation introduces variations, testing the theory against known phenomena. As AI calculates potential universes, some where time flows backward, others where gravity is an emergent property rather than a fundamental force, it uncovers insights that redefine our understanding of existence itself. Through AI's iterative process, the TOE transforms from an abstract idea into a framework we can test, explore, and expand. Implications of the theory of everything. The theory of everything has profound implications not only for science but also for society, technology, and even philosophy. If we could fully grasp the TOE, it could open doors to new technologies, such as controlled gravity, advanced quantum computing, and perhaps even the manipulation of time. Imagine gravity fields created at will, allowing for frictionless travel, or quantum computers that tap into cosmic energy, transforming computation as we know it. The TOE could also illuminate fundamental mysteries about consciousness and life. If reality is a network of interconnected fields, could our minds be more than mere biological phenomena? Some scientists speculate that consciousness itself might be a resonance within the space-time web, giving rise to a theory that views life as an integral part of the universe's structure, not a random occurrence. Such discoveries would force us to confront existential questions. What does it mean to be alive in a universe woven together by a common energy? Are we truly separate entities, or are we interconnected by forces that bind us as firmly as gravity? Ethics and reflections. The theory of everything may unlock vast power, but with it comes immense responsibility. How would humanity handle the ability to manipulate space-time, potentially altering the very laws of physics in localized regions? The ethical considerations are staggering. Altering gravity, for instance, could have irreversible environmental impacts, affecting planetary orbits or atmospheric stability. Moreover, the TOE challenges our understanding of fate and free will. If particles resonate across vast distances, does this imply a predestined connectivity, where every action has repercussions beyond our immediate surroundings? Or would it empower individuals with the knowledge that every choice resonates universally, a reminder of our shared existence? Closing reflection. As AI unveils the theory of everything, humanity stands on the brink of a new frontier, a frontier not of land, but of knowledge. This chapter in our journey invites us to question not only the mechanics of reality, but the purpose behind it. With the TOE, we glimpse a universe more interconnected and more intricate than we ever imagined. But as we push the boundaries of discovery, we must ask ourselves, are we ready for the answers we seek? How will the power of ultimate knowledge shape our future, our relationships, and our responsibility to the cosmos? What mysteries lie beyond the TOE? And will humanity's pursuit of knowledge propel us toward enlightenment, or will we stumble upon truths that are as unsettling as they are awe-inspiring?